So hopefully you guys got to see in the last lab the results of this. What we're showing, the yellow and the red, they were a little bit more dim, and the purple and the blue, they were a little bit more brighter. It's because those were allowing the cooler colors to pass through, and the cooler colors have more energy to them. What we're looking at now is going to be the speed of light and a few calculations, and then we'll take a look at how light, of course, diminishes with distance. So looking at the speed of light, the speed of light is represented as lowercase letter c. And the speed of light, that's this right here. And again, it is taking the wavelength and multiplying by the frequency. If you take a look at the units, wavelength is measured in meters. Frequency is measured in hertz. Hertz is, the units of hertz is actually 1/seconds. It's the number of times something occurs per second. It's the frequency. How often does it occur every second? So 1 hertz is 1 wave per second. 2 hertz would be 2 waves per second. So if I plug in and substitute 1/seconds, we get meters times 1/seconds. And therefore, we're going to have the units are going to be meters per second, which that's velocity, and that's going to be speed. So you might have some questions that look something like this. What color of light has a frequency of 5.5 times 10 to the 14 hertz? So what color means what's the wavelength? That's what this question is asking. Because remember, the color is measured with the wavelength between 400 and 700 if it's visible light. So let's start off with the formula. Speed is equal to wavelength times frequency. We want to solve for wavelength, so we're going to divide both sides by frequency. Divide both sides by frequency. Now, the speed of light is a constant. So the speed of light is going to be 3.00 times 10 to the 8 meters per second. So that's what we have to plug in for this here. So my lambda, or my wavelength, is going to be equal to the speed, which is 3.00 times 10 to the 8 meters per second, all over frequency, which is given to us in the problem, 5.5 times 10 to the 14 hertz. Now remember, hertz, the units is 1/seconds, so we've got 1/seconds. And then you'll notice that the seconds is in the denominator, both in the numerator and the denominator, so those will cancel, and that will be left with meters, and meters is the measure of wavelength. So when you do this on your calculator, you're dividing by something in scientific notation, so you're either going to have to divide by this, then divide by this, or you're going to have to use parentheses. So make sure to use parentheses on your calculator, or if you can make sure to divide by both of those. So your answer, if you plug in this in your calculator, the wavelength comes out to be 5.5 times 10 to the minus 7 meters. But this does not fit within our 400 to 700 nanometers. So remember we talked about what a nanometer is equal to. 1 nanometer is equal to 10 to the minus 9 meters. So I want to cancel my meters and convert to nanometers. So 1 meter is equal to, there's 2 ways of looking at this. 1 nanometer is 10 to the minus 9, or you can also say 1 meter is equal to 10 to the 9th meters. 1 meter is equal to 10 to the 9th nanometers. So 1 meter is equal to 10 to the 3 millimeters. 1 meter is equal to 10 to the 6th micrometers. 1 meter is equal to 10 to the 9th nanometers. So this is the way that I usually prefer to do this. You can also, if you wanted to, you could say that 1 nanometer on the top is equal to 10 to the minus 9, but then you're dealing with negative exponents. So this is the easier one to use. If you plug this on your calculator, this will come out to be equal to 550 nanometers. So we found what the wavelength is, but what color is that? If you remember from chemistry, we're going to be looking at VIBGYOR again. Okay, and this is 400 nanometers down here. This is 700 up here. Now, these are just actually approximate numbers. It's close to 400 for the violet. It's close to 700. Truly, this is actually ultraviolet, but we're just going to use 400 for this. And this can be broken up into nice 50 increments. So each of these colors represents close to the color with the nanometers, close to the color of what it represents. So 550 would be then green.